Okay, so this is a review for our Unit 7 exam that does have a lot of past unit information. I'm going to start with psychoactive drugs. Those are substances, if you remember, that are introduced into the body. They could be legal drugs that people use, or they could be illicit drugs. And they serve as either agonists, and that means that they serve as a drug that would mimic a neurotransmitter's effects or stop its reuptake. Or they could serve as antagonists, which would just block a neurotransmitter. Okay? So we have a couple terms associated with psychoactive drugs. We have addiction, and that's when the body gets so used to a drug, it develops a tolerance for it, and so as a result of that, you need to take more and more of it. People then become addicted to it because they have both physical and psychological reactions to the absence of that drug. Now, the most addictive drugs are things like sedatives. Those are barbiturates, and alcohol is a sedative. And, of course, opiates, which are a type of a depressant drug. But opiates are also serve to relieve pain, and they become very addictive. Okay? So we know that somebody's addicted to a drug because they will experience some kind of a withdrawal symptom. And it is uncomfortable. It's just stressful. And the thing is, though, that most withdrawal symptoms can be overcome with time without danger to the body, except for that which is associated with alcohol withdrawal, in which case you could stroke out if you just go cold turkey after being, consuming lots of alcohol for a long period of time. So when we talk about dependency on a drug, there are two different types of dependencies. There's those that are physiological, right? That where there's a biological addiction to it, and if you don't take the drug, you're going to have physical withdrawal symptoms, shakes, like I said, a stroke if it's alcohol, body sweats. Okay, but there's also psychological dependencies, and people often they will relieve their physiological dependency first, like in a few days, but they still are psychologically dependent on that drug for a sense of well-being. So the most common drug classes, and we're going to talk about classes of drugs, are depressants, stimulants, and hallucinogens. Let's start with depressants. They work on your central nervous system to slow it down. It's a depressant. So when I say slow down your central nervous system, it's also going to slow down everything that your central nervous system controls, which includes your peripheral nervous system, your hands, your legs, your heart, your stomach, etc. Okay? So the common drugs that we think of as depressants are classified here. The few that you may not recognize immediately are barbiturates and benzodiazepines. Barbiturates are an old class of drugs. They're not frequently prescribed anymore because they are very addictive. Benzodiazepines took their place, and they include anti-anxiety medications like Xanax. Now, opiates are a depressant. They also slow down the central nervous system, but they, of course, relieve pain because they act as an endorphin agonist. Okay, so they're mimicking the neurotransmitter that you have, natural one called endorphin. Those are things like heroin and morphine and Oxycontin. You'll notice when we take a look at drugs that if they're all benzodiazepines often end with an AX or an AC. Opiates often end with an IN or INE, and that's not a mistake, okay? It's not a coincidence. That's just how they are named as such. So the depressants affect, all depressants will affect your GABA. And if you might recall, GABA is a neurotransmitter. It's your body's main inhibitory. It's what stops an action from happening, okay? So if GABA is going to slow the body down. So if you take alcohol or barbiturates, they act as a GABA agonist. So they slow the body down. Exactly why you should not be driving when you drink alcohol or take a barbiturate. Now, stimulants would be to do the opposite as a depressant. They excite neural activity. They're going to activate your central nervous system, but specifically your peripheral sympathetic nervous system. Okay, so remember the autonomic nervous system is part of your peripheral nervous system. It's made up of your sympathetic, which is your body's fight or flight reaction, and your parasympathetic, which brings your body back to homeostasis. So the sympathetic nervous system includes things like dilating your pupils so you can let more light in to respond to a stressful event. Or it could drop your appetite because there's no need to be eating or digesting when you're dealing with a stressful event. Okay, so all stimulants will do that. And the common drugs you'll see here are things like methamphetamines, amphetamines, which of course are legal and prescribed, like Ritalin and Adderall, not ecstasy, cocaine, nicotine, and caffeine. Okay, and they all affect the nervous system by acting as norepinephrine agonists. In other words, epinephrine or norepinephrine are both they're neurotransmitters that will stimulate. They're released right when your sympathetic nervous system is activated. So they all serve as that. They do lots of other things too, but we're going to stick with the main effect of these drug stimulants, which are norepinephrine agonists. They increase the availability of norepinephrine. The third classification of drugs are hallucinogens. And when we talk about a hallucination is when there's a false sensory experience. You see something that's not there. You feel something that's not there. You hear something that's not there. In fact, most people think about hallucinations as seeing things. The truth is, most hallucinations are auditory. In other words, they're usually things you hear that aren't there. So hallucinogens all will distort a person's perceptions, right? They're also known as psychedelic drugs. Okay, so the common ones we know of are marijuana and LSD and PCP and mescaline and psilocybin, and they affect lots of different neurotransmitter systems. But again, we're going to stick with the main one that causes hallucinations or is associated with hallucinations, and those are dopamine. So dopamine agonists, and the more dopamine you have flowing throughout your body, the more likely you are to hallucinate. Okay, so those are your psychoactive drugs. And I'm going to go back to our terms list here, and I finished doing that one. We're going to go to the limbic system, parts and functions. I'm going to go to slides 13 through 17 directly. Okay, so let me go ahead and do that. Okay, so let's present from this slide. If I can. I don't remember to do it. I'll just do it here. Okay, so we're going to start with the limbic system. It regulates motivation, emotion, and memory. So that's really important. If you get a question on an exam, if it says, something about motivation, something about emotion, something about memory, you really need to start thinking about what are the parts of the limbic system. So we have the amygdala, which is more associated with emotions, the hippocampus with forming memories, specifically explicit long-term memories, and the hypothalamus, which regulates our body's main system. So it's the motivation to eat, to drink, to have sex, to activate our nervous system for fight or flight. So it has the motivation to do things that help us to survive. Okay. So let's take a look at the amygdala itself. It is responsible, again, for the memory of emotion, as well as emotions such as fear and anger. And it also controls those automatic or autonomic responses associated with fear. Heart rate increase, right? Pupils dilate. The hippocampus, and then we go back to the amygdala. The reason we're looking at the amygdala, one of the parts of the nervous system we want you to know for this unit is, of course, this is part of the low road. Zejonc and Ledoux talked about the low road to an emotion, that sometimes we experience an emotion like fear or anger without it getting processed by our cerebral cortex, right? No cognition involved. So the amygdala is the low road to emotion. Now, the hippocampus is about making new memories. It also helps with spatial navigation, so trying to find your way back out of a maze would be using your hippocampus, or trying to follow a map and directions, or trying to figure out how you would rearrange your room, just imagining in your head. A lot of that spatial orientation as well as navigation. Okay, moving on to the hypothalamus. Hypothalamus regulates our entire endocrine system. The hypothalamus is actually located very close to the pituitary gland, and that pituitary gland is what emits hormones, right, that tell other glands of the endocrine system to do their job. But the pituitary gland doesn't do that on its own. It gets its instructions from the hypothalamus. So this has also a very specialized center. When we talk about the hypothalamus, it does help to regulate our circadian rhythms. Those are the rhythms that fluctuate in our body about every 24 hours, like our wake and sleep cycles and our body temperature. And it does so through a very specialized structure called the suprachiasmatic nuclei. And that suprachiasmatic nuclei is detecting incoming light. And when light is low, okay, and light is high, it obviously denotes that we have a cycle going on, okay? So the other part of the hypothalamus I don't have on here, but of course you would need to know for this unit, it's part of our motivation, are the lateral and the ventromedial hypothalamus. Lateral has the word ate, and when stimulated, it makes you want to eat. The ventromedial hypothalamus is our satiety center. Okay, so it's not shown on this particular slide, but it is something from this unit that we want you to know. So, and again, I have right here a picture of the hypothalamus. It is a pretty complex structure. So you can see that you don't need to know anything really from this slide other than just remembering that because it's complex, it is going to secrete hormones, which stimulate the pituitary gland, which stimulate the rest of the endocrine system. Okay. Now, there was a little quiz. If you decide to do this on the slide, you can. I'm going to go and talk about the, I think we're going to stop right there, actually. Yeah, we're not going to do any more from this slide. We don't need to. I'm going to go back to our terms list, and I'm going to go to the brainstem. Okay. So let's take a look at the brainstem just to remind ourselves that we have our forebrain, which is the thinking part of our brain and a lot of our limbic system, the midbrain, which we don't spend any time on in this class, and our hindbrain, which is what we're going to be talking about today, which the brainstem is part of. So the brainstem, there is a small piece of it that's in the midbrain, but it actually does end up in the hindbrain. But if we just think about the brainstem, it regulates your attention, your ability to pay attention to a stimulus. It regulates your ability to be awake. That's arousal. And of course, because it regulates your ability to be awake, it also regulates your ability to sleep. So yes, it does work at the hypothalamus, obviously, because the hypothalamus also is responsible for the wake and sleep cycles. But when we think about the brain stem itself, it has a lot of functions that are absolutely vital for survival. Let's take a look at first the medulla. And I would ask you to make sure you do look at the diagram for the brainstem in particular, and note that the medulla is located below the pons. The reticular formation runs through the pons, okay? And at the top of that is the thalamus. So let's take a look at the medulla. It controls vital involuntary functions. What are those? Breathing, okay, your blood pressure, your swallowing. Okay, if you can't swallow and you can't eat, you will die. Okay, sneezing. I'm not sure why sneezing, but maybe just to get things out of our nose. But it takes information that's coming up through the spinal cord. It passes through the medulla, and it serves as a crossover point. Everything from the right side of my body, right, will cross over at the medulla and end up in the left side of my thalamus, where it'd be routed to the correct part of the brain. Okay. So medulla, vital, involuntary life functions. The reticular formation is a lot of cells. As you can see, it's a long structure. It runs up through the pons. It's not only active in terms of our ability to be awake or to sleep, but it's also about focusing and attention. Specifically attention to a new stimulus. So it only brings in to the brain stimuli that are novel or new, because we don't need to pay attention to, for example, to the tag on the back of our shirt or the fact that you're wearing a bracelet or a ring or socks, right? The reticular formation will bring in novel or new information. So in that way, we call it a sensory filter. But it is really important because if your reticular formation is damaged, you may not become awake, right? You may not wake up. That is when we talk about high-level neck injuries, we are talking about potentially damage to the reticular formation inside the pons, and you might end up in a coma. Okay, so here's your pons, and it also, like the reticular formation, plays a role in sleep and arousal, but it indeed coordinates unconscious movements. Again, swallowing, so along with the medulla, it works with swallowing, and your bladder, and your posture, and your eye blinking. Okay, medulla is pretty recognizable on any kind of MRI because it has got a little bit of a bulb-like look to it. Did I say the medulla? I meant the pons. Okay, and then we have our cerebellum, and that's located back here in the hindbrain. Okay, it's often thought of as the little brain, and it's about controlling balance and complex voluntary movements. And we now know that the cerebellum likely stores many of our implicit memories. Okay, when I say implicit memories, those would be, for example, classically conditioned associations. Like some of you said that you get sick when you smell a food that made you sick in the past. That's likely due to the cerebellum. Okay, we're going to stop here on division on the brainstem, and we're going to go back to our terms list. Okay, so we've made it through Unit 2. We're going to get to Unit 3, Sensation and Perception. And we're specifically looking at perceptual organization. We bring up the term Gestalt, and Gestalt is the idea that the whole, is greater than the sum of its parts. So if I were to just take small parts of something, and I don't give you all of it, like if I say a sentence like, please go shut the, most of you would fill in as door, because the whole is greater than the sum of its parts. Okay, we perceive things as meaningful wholes. Okay, wholes meaning WHOLES, not holes like in the ground. So this is all about top-down processing. And when we talk about top-down processing, it's about us placing meaning on something. Okay, bottom-up processing is simply sensations, individual sensations that are coming into our body through that reticular formation, and then the cerebral cortex makes sense of it. That's top-down processing. Okay. So I'm going to, the law of prognance. That is related, and you won't need to know it for this particular exam, but it does state that we will try to interpret things in the simplest way possible. So that makes sense because we will try to, for example, and we look at perceptual organization, we will see either a vase or two people looking at each other, whatever's the simplest. You might see a young lady looking away or an old lady looking down. Let's talk about the different grouping principles for Gestalt. We have closure, where we tend to close off an object to make sense of it. Remember, the whole is greater than the sum of its parts. We have proximity, where we'll actually look at things that are close to each other and see that they belong together. We see this as I guess what we might call it a dipstick, okay? Going through an S. We don't actually stop our eyes when we start at the top of this dipstick and then start going around the S and then come back to the dipstick, right? We see continuity, okay, so a continuation, okay? Again, let's move down to some of the others that are in here. This is another proximity. You might want to review these. Here's another example of continuity where our eyes follow two keys. Our eyes don't change direction. Okay, and the same thing with this logo here, okay, where this is Hilton in Canada, and you see the maple leaf. Connectedness. If I put a box around something or I put lines through something, we will see them as being more related than objects that are not included in that box or lines. And there's a closure again. You'll see a soccer ball. And of course, closure helps you read the sentence. Okay? The purchase of a home is likely the single most important financial decision you'll ever make. And you don't even need all the letters to do that. And then similarity. We will see these as, we'll perceive elements that are similar to each other as being related to each other. So we will see groups of triangles and circles. Okay, so those are the Gestalt grouping principles. So going back to our terms list here. I realize there's probably more to it at Unit 3 than what I just did, so please review some of these others. Perception, transduction, perceptual constancies. I will put links in there. I must have failed to do that. We're going to move on with this video. We're going to go into observational learning. So we're in our learning unit. This is the behaviorists. Okay. Sometimes, we learn through punishments and reinforcements, but what if we're not directly the recipient of that punishment or the reinforcement? Can we still learn? And the answer is yes, we can absolutely learn without demonstrating that we've learned it at that moment in time. And it's called the social learning theory. Albert Bandura did that study with the Bobo dolls. And he found out that people might reproduce the behaviors of others if they saw that the other was receiving a positive reinforcement. We also learn through negative reinforcements. We learn to avoid certain stimuli. For example, you might learn that if you come to school late, that you're going to get detention. And then you didn't have to learn it by getting detention. You just watched somebody else in your class get detention. That's social learning. In the famous Bobo doll experiment, we saw a model beating up on a doll, and the children who watched that model beat up on the doll found ways, novel ways to play with the doll that were more violent than children who did not watch the model behave aggressively towards the doll. We know that modeling, though, doesn't, modeling, you're not going to necessarily reproduce a behavior. There's a 4-step process here. We know that you have to pay attention and remember. Okay, so there's attention and there's retention. Okay, but we also know that you have to be able to physically reproduce it. Okay. And finally, you have to have the motivation. You have to expect that if you reproduce the behavior, okay, that there is going to be some kind of reinforcement that's valuable to you. That's kind of like that expectancy value theory. You might expect you could do something, but you don't value the reinforcement, so you may not be motivated to do it. Okay, the last thing in observational learning is the biological process behind it. We know that in the frontal lobe of our brain, that's right behind your forehead, that there are neurons that seem to be active when we perform an action or when we observe somebody else performing that same action. So these mirror neurons are believed to be sort of the reason for empathy, but also the reason for our ability to learn things through observation. The same neurons that fire when I play tennis would be the same neurons that would fire when I watch somebody play tennis. Okay, I'm not going to go into the video. Okay, moving out of this, and we're going to move into blind spots in problem solving. Okay, so in blind spots in problem solving, I'm going to go to slides 21 through 26 here. Okay. Okay, so blind spots, typical mistakes that humans make when solving problems. You all did a FRQ on this one. It was about somebody who was a murder that had happened, and you had to decide how to advise the police to avoid blind spots in problem solving. And one thing was a representation failure, representing a problem in the wrong way. And we looked at a series of, if you remember, numbers, and they were arranged in alphabetical order, but many of you were trying to figure out the sequence of numbers based upon a mathematical formula. Just like it was hard for you to solve this problem of connecting the 9 dots, a lot of people represent the problem as being confined to the 9 dots, but instead, of course, you can go way around the back, way around it and go outside of the boundaries of those 9 dots to solve the problem. The other one was functional fixedness. That's the tendency to think about an object only in terms of its usual functions. Now, if you remember Piaget talked about the idea that we have schemas. And so I have a schema, for example, when you're younger and you learn what a paperclip is, you know that it puts papers together. Okay, so you've added a new schema, you've accommodated, and anytime you see a paperclip, you say, oh, I can paperclip papers together, I could paperclip folders together, and you are assimilating. But you can use a paperclip for something other than clipping things together, right? You know that. You know you can unfurl the paperclip, you can unbend it, and you can use it to reset a phone if you need to, or a computer by sticking one of the ends in. You can probably scrape off your nail polish if you have that. You can use the end of it for that. There's a lot of ways you can use a paperclip. So you're able to accommodate your schema for paperclip as you get older so that you are not functionally fixed, that a paperclip only has one use. Our mental set is when we use our experiences to solve problems that have worked for us in the past. So it's a lot like a representation failure, because representation failures are after all due to a mental set. We get stuck on a problem-solving strategy that might have worked in the past. The other thing we tend to do is to search only for information that verifies our beliefs. So if you were to believe, I think the FRQ, if you were to believe that the woman with mud on her knees, if you remember the FRQ, She was gardening, and the garden tools were the murder weapon. So if you were only to think that the woman who was the gardener was the murderer, you would only interview her and you would only look at the garden tools. You would ignore all the other things at the crime scene. Why? Because you're only looking to verify your beliefs. And of course, we see that, in terms of political biases too, right? People tend to watch the news services that meet their political beliefs. We talk about belief perseverance. Now we start with a little different than confirmation bias, and it's an important difference. So if you refuse to believe you're right or wrong, you refuse to believe that you're wrong in spite of contradictory evidence, you're engaged in belief perseverance. Okay, so we'll take climate change, and climate change deniers will see evidence of climate change. You can see that there's temperature changes in the last year, but they'll continue to believe it doesn't exist. So they have a belief, climate change doesn't, there's no climate change going on. Then they get evidence to the contrary. And we're not talking about just, me telling that person that, but them actually seeing verifiable evidence. And then continuing or maintaining that belief is the third step. So belief perseverance is something we tend to do. It's really hard for us to get rid of an initial belief. And if let's say somebody did see this chart of temperature change in the last 50 years and they experienced dissonance, imagine they might use an ego defense mechanism like justification, rationalization, saying, well, yeah, but the world heats up and cools down, and it's been doing that for millions of years, and it has something to do with humans. So that might be your rationalization when you're confronted with disconfirming evidence. Okay, that is it for blind spot. I'm sorry, which one was that one? That was blind spots and problem solving. I'm going to go to biases and judgment. Again, we did use this in that particular FRQ with the murder on Spoon. I think it was on Spoon Street. So we often, I'm going to move down to the actual terms. We often will make a judgment or make a decision based upon, mostly judgments, based upon what first comes to our mind. Okay, it's called the availability heuristic, and a lot of you have been coached by your teachers in this class that if you see availability heuristic on an FRQ, you want to use the term, you want to use the concept of a person making a judgment based upon the first thing that pops into their head. So the immediacy of that particular thought, it's what's driving their judgment. Now, a lot of you get this confused with recency. So you'll say, well, they recently saw on the news that there was a plane crash, so they're more afraid of planes because of that. Well, that's recency. You'd have to tie that into immediacy. So if they saw something recently on the news that talked about plane crashes, then when somebody says, are planes safe to fly, their judgment that comes to mind first, okay, because of the recent news events, is that planes are not safe. Okay, so, but it has to be about immediacy, the first thing that comes to your mind. Okay, so what's the first thing that comes to your mind? Now we're going to talk about a different heuristic, but not the first thing. What is a prototype of a librarian? So a lot of people think option one is a prototype, and that's a different type of judgment. It's called the representativeness heuristic. So whatever matches your idea, your stereotype, is often a judgment that we make. So we often make judgments based upon stereotypes that we have. And it's about our estimating the likelihood of something based on how stereotypical it seems or how much it matches a prototype. Okay. So I'm going to move through to the anchoring effect. The anchoring effect is when we take an initial value, it's typically a number, as an anchor. Okay, and then we use that as a reference point for making other numerical decisions. So it happens in shopping a lot, where you're given by the stores an anchor of the retail price. It's $300 for this jacket, but hey, we're going to give it to you for just $150. Well, they anchored you to $300, so $150 seems like a great deal. Okay. And then, of course, there's the framing effect. That's the biasing effect that we have when we encounter a way in which a question or a choice is framed or worded. So it can affect our decisions. And then the previous, let me see here, sorry. Let me go back to the previous slide there. Which would you choose, a vaccine that saves 200 lives or a vaccine that says there's a 33% chance of saving all 600 people or 66% possibility of saving no one? Well, most people choose vaccine A, even though these two are exactly the same. Okay. Then we have the overconfidence. So the idea that we tend to overestimate the accuracy of our predictions. We do that frequently, that we think that, it might relate to, actually, I'm thinking about it, it relates to an emotion, that durability bias, right? Remember how we have the bias to think that a bad event and the bad feeling we have is going to last a long time? That has to do with overconfidence. We overestimate the accuracy of our predictions. Okay, so that's a good link to make between these units, overconfidence and durability bias. Okay, I'm writing that down because it just kind of hit me, and I want to make sure I put that out there again. And then there's the illusion of control. We tend to think we can control chance events, and that's why people, hit an elevator button when it's already lit, or hit the walk button when it's already lit. It is an illusion of control, and that happens with people when they pick, for example, their own lottery numbers. They think that by picking them, they have control over the outcome, but of course we do not. Okay. And this illusion of control leads to a concept called gambler's fallacy. This is, again, the idea that a random process is self-correcting. If I were to flip a coin 100 times, I kept getting tails, you would think it was going to have to correct itself. Eventually, it was going to have to get heads, but that's not quite the case. Okay. I'm going to go ahead and move out of that one. And we are moving into, let's see here, memory. Okay. So I do want to make sure that I'm not going to spend too much time on this one, but there are a lot of things in memory that are important to know. The most important thing is that information processing model, that we encode things into our memory, we store things, and we retrieve them. And there's this Atkinson-Shiffrin model. It's this idea that there are stimuli that recorded briefly in our sensory memory. Here it is right here. Iconic memories and echoic memories. Iconic are visual, echoic are auditory. And they're stored very, very briefly, no more than 4 seconds, and they're literal copies. And if we pay attention to it, so it passes through that reticular formation, we will bring it into our short-term memory. Okay. Now that short-term memory we know isn't just for short-term memory that's coming in. It's not just for new things, but it's also when we pull things out of storage and we work with them. So we can increase our short-term and our working memory by rehearsing something, by maintaining it, by saying things over and over again. Now we may, if we can encode it into our long-term memories where we can retrieve it to work with it later. Okay? So this is the idea of working memory. It has a lot of different functions. We don't have to know those necessarily, but you might want to review them. Now we know that some things are automatically processed and some things require effortful processing. A lot of our implicit memories are automatically processed, so without our awareness. So we kind of skip that whole short-term memory. We go straight from seeing it or hearing it directly into long-term. Explicit memories typically require effortful processing. And when I say effortful, it doesn't mean that you have to spend a lot of effort doing it, but there is attention and conscious effort that's paid. Okay? So you should know the difference between implicit and explicit memories. Okay? And the big thing about implicit memories is that they include procedural memories, like riding a bike and climbing stairs. And we know that implicit memories are stored likely in both the basal ganglia and the cerebellum, with procedural memories in the basal ganglia, and things like being primed or conditioned associations in the cerebellum. Okay. So take a look at this hierarchy of memory. We have explicit and implicit memory and the different types, and you should probably take a look at that, be able to recognize them. Okay. And that is our introduction to memory. I talked briefly about sensory memory. Let's take a look at retrieval. So we're talking about memory retrieval. Okay. There's a difference between recall and recognition. And please know the difference between that. When you recognize something, and most of you, when I give you multiple choice questions in class, you can recognize the correct answer. It's really, really hard to recall something. Relearning simply refers to the ideas of what you're doing right now. You are relearning information that you've learned in the past. Now, as we talk about some of it, you may have no clue or no memory of it. It's there, but you just don't have any memory of it. You haven't really built strong connections. But we do know that the more you revisit material, the less time it takes to relearn it, which is why we give you these cumulative exams. Okay? I'm just moving through some of the things that are important. Let's talk about encoding specificity. Sometimes when we remember something or we recall something, we recall it because of the context in which it was originally encoded. One is called, that's context dependent, is that if you encode something when you're in your bedroom, learning things in class, you'll have a better time remembering them when you're in your bedroom. That's contextual. But we also have state-dependent memories, mental, emotional memories, physiological memories. So we encode along with all the information you're learning in class with your emotional state, your mental state, your physiological state at that moment in time. So if you always attend a class in the morning between 9 o'clock and 10 o'clock, and you have to recall information, you probably want to recall it during that 9 to 10 o'clock period. Why? Well, because you'll be in the same physiological and emotional state. A little bit tired, maybe, a little bit groggy, but still pretty alert. Okay? Okay. The serial position effect just refers to the idea that we remember a lot of stuff at the beginning of an interaction, a lot of stuff at the end of the interaction, but not that much in the middle. This is called the primacy, because it's the first thing we come across, and this is the recency. Okay? And the primacy effect is responsible for those enduring first impressions that we have. Okay, moving out of this, and we're going to move into forgetting. And this will be the last of what we do for reviewing the previous units. When we talk about forgetting, there's a lot of reasons why we forget. Some are biologically based and some are not. So there are people who cannot form a new memory, like Henry Malazan. He could not form a new memory, and why not? Well, his hippocampus had been removed to stop the spread of seizures. Now, through this case study, it was a very unusual case that presented itself. We found that the hippocampus is essential to forming a new long-term memory. And the fact that he could not is referred to as anterograde amnesia. Anterograde amnesia, the inability to form a new long-term memory. Now, we're talking about a new long-term explicit memory, not the implicit memories like riding a bike or playing the piano. Retrograde amnesia, and if you think about the prefix as retro, we have problems with the prefix. We have problems with the old memories. And that's typically due to some kind of traumatic brain injury to the cerebral cortex. And it's often temporary because our brain is plastic. We can rewire our memories. Okay. I'm not going to get into too much of this. Let's talk about encoding failure. Sometimes we don't pay attention to something, so of course we don't encode it. Okay, so that's a reason we might forget something. Okay. When we forget things, and if we do encode it and we forget it, we see that there is often a decay over time. But most of what you're going to forget within the first day. Take a look at that. About 67% of what you're going to forget the first day after you learn it. Okay. And now I'm going to move to interference, because a lot of people confuse interference with amnesia. Remember, interference is not biologically based. And we gave you a acronym to remember at PORN, that proactive interference is when the old interferes with the new. And retroactive is when the new interferes with the old. Okay, so if you want to remember that acronym, that will help you. Okay, and that is basically what I wanted to cover. So I did not cover all of sensation and perception in this. So I would encourage you to maybe look at, and like I said, I'll put links in there, but look at the top down, bottom up, and understand what transduction is and depth perceptions. And that's about it. Okay, so if you have any questions, please feel free to log them into the discussion board that I set up for you. And have a great day, and I will see you all tomorrow.